All right, good morning everyone. We are working on 4.5 still. So my last video I got through questions 1 through 5, or no, 4. So today we're going to start on question 5. And still doing the same thing, so just lots of repetition. Get through as many of these as you can. These are all written in the right format for you. They're all in standard form. They all have one variable that's going to cancel. Now that won't always be the case, but I want you guys to get lots of practice. Okay, so write the two equations together. Make sure you're lining up your variables. Make sure you line up the constants on the right hand side, and then add down. So 3x plus 4x is 7x. Negative 3y plus 3y cancels each other out. Negative 21 plus 7. Ooh, that's going to make me think for a minute. 14. Yes, negative 14. So then we have 7x equals negative 14. Divide both sides by 7. And we end up with x equals negative 2. All right, so that's half of our answer. Now I'm going to go back here and I'm going to choose one of these equations. I'm going to choose this one down here because it doesn't have any negatives at all. And rewrite it. So 4x plus 3y equals 7. Now I'm going to take what I already know about x and plug it into this equation. So I'm going to write the 4, and then instead of the x, we're going to put in a negative 2. I'm going to put it in parentheses to keep that negative with it. Make sure you remember its multiplication. So 4 times negative 2 plus 3y equals 7. And we have negative 8 plus 3y equals 7. So then we're going to add 8 to both sides. And we get 3y equals 15. And then divide both sides by 3. We get y equals 5. So that's our second answer. So final answer is negative 2, 5. And if we wanted to check that, we would go back to one of the original equations. Let's pick 4x plus 3y equals 7 again, and plug in the values we got. So 4 times negative 2 plus 3 times 5. 4 times negative 2 is negative 8. 3 times 5 is 15. So negative 8 plus 15 equals 7. And that's exactly what the equation says. So we are good. That checks. Okay, number 6, more practice. So we have 1x minus 3y equals 10. Line up our variables. So negative 2x plus 3y equals negative 8. Draw a line and add down. So 1x plus negative 2x is going to be negative 1x. Then add down your y's. Those are going to cancel. And then that equals 2. So 10 plus negative 8 is 2. And then we're going to divide both sides by negative 1. So we get x equals negative 2. And so we've got half of our solution. They want this as a point. Then choose one of those equations. I'm going to choose the top one. So I have 1x minus 3y equals 10. And then I'm going to plug in negative 2 for x. So I have 1 times negative 2 minus 3y equals 10. So 1 times negative 2 is negative 2 minus 3y equals 10. And then add 2 to both sides. And we get negative 3y equals 12. And divide both sides by negative 3. And we get y equals negative 4. So y equals negative 4. There we go. And then plug that in. Get negative 4. And that's our solution for number 6. Okay, I skipped forward a little bit in here so we can find something that looks a little bit different. All of the ones previous to this are going to be the same repetition, just different numbers on all of those first 9 questions. So now on this one, not that it's much harder, but I think this is the first time that we see that the x variables are going to cancel. And it always seems to be a little bit more difficult and confusing when there's no actual numbers attached to the variables. So I wanted to look at this one. Okay, so we've got negative x plus minus 3y equals negative 15, and x minus 2y equals negative 10. So they're both written in standard form, and this time our exact opposites are the x variables. So we have a negative x and a positive x, and so those are going to cancel each other out. And then we have negative 3y minus 2y is going to be negative 5y, and then negative 15 minus 10 is going to be negative 25. So we have negative 5y equals negative 25, and then divide both sides by negative 5. So our negative 5's cancel, and we have y equals positive 5. So our negatives cancel. 25 divided by 5 is 5. So now we have that y equals 5. So in this case, we're going to have the second half of the point. Now we do the same thing. Go back over here, choose an equation. I'm going to choose the second one. X minus 2y equals negative 10. And now we're going to plug 5 in for y. So we have x minus 2 times 5 equals negative 10. And so we get x minus 10, so negative 2 times 5, that's going to be a minus 10 equals negative 10. Then we're going to add 10 to both sides. And it's okay to get 0. Remember, it's okay to get 0. We're going to add 10 to both sides. The 10's cancel. Over here on the right-hand side, we have negative 10 plus 10. Well, you can think of them as, yes, they do cancel, but what do they become? They become 0, and that is okay for an answer. So we get x equals 0. So the solution to this equation is the point 0, 5. Okay, number 11. So again, looking at this one, they're both in standard form. Exact opposites this time, again, are going to be the x's. So rewrite, we have negative 4x minus 6y equals 8, and then 4x minus 3y equals 10. Draw a line, add them down. Our x's are going to cancel. We have it negative 6y minus 3y is equal to negative 9y. And then on the right hand side we have 18. So we're going to divide both sides now by negative 9. And we have y equals negative 2. So then we're going to plug that. I'm going to choose the second equation. We're going to plug into that one. So the second equation is 4x minus 3y equals 10. And we're going to plug in this y equals negative 2 here. So we have 4x minus 3 times negative 2 equals 10. So 4x plus 6 equals 10. And so we're going to subtract 6 from both sides first. I'm going to run out of room. So we're going to bring this all the way over here. So subtracting 6 from both sides, our 6's cancel. We have 10 minus 6 is going to be 4. I'm going to bring over here. On the right hand side, we're going to have 4. And then on the left hand side, we also have 4x left. So divide both sides by 4. And we end up with x equals 1. So final answer, we have y was negative 2 and x equals 1. So write that as an ordered pair. So x is 1, y is negative 2, and that's your final answer. Okay, we kind of skipped ahead here a little bit. Question 19 is where we get a little bit more of a change. So, looking at these two equations right here, they are both in standard form. That's the first thing we need to check for, so we're good there. But, do we have anything that is a complete opposite? And in this case, no, we do not. We have something that is exactly the same, and so those are going to be easy to make exact opposites. But it adds one more step onto what we need to do. So when I have numbers that are exactly the same, or variables, so I have a 4x plus 5y equals negative 23 for my first equation. Oh, I can do better than that. There we go. And then for my second equation, I have 4x plus 2y equals negative 14. So what we notice is that we have 4x and 4x. Now when I go and I draw a line and add these two down, my 4x's are not going to cancel. I'm going to actually end up with 8x and then a 7y here, and that's not going to help me any because I won't have gotten rid of one variable so that I can solve for the other. So we have a little trick that we're going to do, and we are going to put the second one in parentheses, the whole equation in parentheses, and then we are going to multiply a negative 1 to the outside. And so we get the distributive property, and remember that's our leapfrog. That negative 1 is going to bounce through every term, including what's on the other side of the equal sign. Now that's something different that we haven't done before. We've never had to multiply throughout the whole equation, including what's on the other side of the equal sign. But the property that we're using here is whatever you do to one side, you have to do to the other. So we're really multiplying negative 1 to the left-hand side of the equation. But if we multiplied it to the left-hand side of the equation, we would also have to multiply it to the right-hand side. And so we can do that with just one step of multiplying the whole equation by negative 1. So let's write that again. So we have 4x plus 5y equals negative 23. And then for our second equation, we have 4x plus 2y equals negative 14. Now, when I multiply this whole equation, I'm going to change colors, multiply our whole equation by a negative 1, and we distribute that through every single term. Okay. So what that's going to do is negative 1 times 4 is going to just make it negative 4. Negative 1 times 2 is going to make it a negative 2y. And the negative 1 times the negative 14 is going to make it a positive 14. So now we have a new equation, and let's write over here to the side. So we have 4x plus 5y equals negative 23. And then we have to write the new equation that's inside of our parentheses. That's all we need. So negative 4x minus 2y equals 14. So this is introducing a whole new step that we haven't had to do before. And that is multiplying 1 to the whole equation and distributing. Okay, so make sure you're doing that distributive property. You can think of it as leapfrog if you want to, making sure that negative 1 is multiplied to the whole equation because we need to do both sides. Now we have exact opposites. So that gave me the desired effect. I have 4x minus 4x. And now those cancel. And we have 5y minus 2y is 3y equals negative 9. And then we can divide both sides by 3. And we end up with y equals negative 3. What? Oh, you need future cast. Okay, here, hold on. Okay, sorry about that. All right, so we've got y equals negative 3, and now we need to go back